So this is the first topic or the first section that we are going to talk about. It is 401, and it's basically talking about all kinds of basic properties about the determinant. And in Chinese or high school, we call that as 行列式值. Okay, and I believe we have learned the following basic cases. If you have a matrix, it has 4 numbers. Then its determinant is equal to AD minus BC. And sometimes there are some notation will write 2 bars from here. You will write 2 vertical bars and indicate that's the determinant. But at least for this course, we will just write DET in the front. So you know what it is. And then there is a bit more complicated, but you also know what it is, which is 3 by 3 matrix. And it is the sum of 6 terms. Okay, and I guess I don't want to write that, and you don't want to write that either. I'm pretty sure you know what it is. The point is that you have 3 pluses and then 3 minuses here, right? And so for the determinant of 3 by 3 matrices, you have a 3 plus and 3 minuses. And the 3 pluses are basically the 3 arrows going down, right? You do AEI and then BFG and then CDH. Okay, just try to let you know what I meant. And then for the 3 minuses, then you have 3 arrows coming from the top right to the bottom left. So that's how you do that. And you feel like that's the same philosophy here, because you have one go to the right and then the other coming to the left. And then that's how you calculate the determinant. But however, if you have a 4 by 4 matrix, then it is actually the sum of 24 terms. Okay, so it is not equal. It is not going to be equal to 4 things, 4 pluses that is going to the right, and then 4 minuses that is going to the left. It is just not the same, okay? It's actually much more complicated. It has 24 terms. That's why the high school teacher will stop at 3 by 3 and rarely talk about 4 by 4. And we will tell you how to do that later, but just want to point out the differences. So you know how to do 2 by 2 and 3 by 3, right? And now let me tell you the general strategy to find out the determinant for n by n matrix. Okay, so it follows 4 rules. And the whole idea of the first part of our course, maybe several lessons, we will try to explain why we set up these kind of rules. Okay, the first one, the determinant of the identity matrix is always equal to 1. It's like the building block. The next, we have three types of row operations. And then we want to study how does the row operation will change the value of the determinant. So we have three kinds of row operations. So I will say that verbally, if I swap row I and row j, this notation means that I swap two rows, row I and row j, then basically the value is the same, but you have to add a negative sign in the front. Now you still have another two different operations. So let's say if A, and then we do some operations. For the ith row, we multiply the ith row by k. Again, this notation says that we are going to multiply this ith row by k. And then we obtain a new matrix B. So if a row is multiplied by a scalar k, then the whole determinant is equal to k times the original determinant. The last one is you will take one row, multiply by a scalar, and then add it to the other row. So let's say I want to change the ith row, but this ith row is obtained by the ith row itself plus k copies of jth row. And so this notation says that row I is equal to row I plus k times row j. If this happens, then the determinant of the new matrix is equal to the determinant of the original matrix. So when you are doing the row operations, you can do a lot of this type of row operation, and you don't need to keep track of the determinant. Okay, so the rest of the time, then I will just show you one example and how to do that, and because that a lot of numbers, and I will give the slide to you. So maybe I would recommend that you can first follow what's going on, and then if you want to write it down, I will post the PDF on the Cyber University. So the first method to calculate the determinant is by row operations. And that's actually the most efficient way to do so. So let's first make a note. The determinant of a matrix that is diagonal is equal to the product of all the entries on the diagonal. Okay, the reason is simple because you can do the row operation of this and make it into 1, 1, 1, 1 by multiplying, or the other way, let's see this way, you can start from 1, 1, 1, 1, and which has determinant equal to 1, and then you multiply by 2, multiply by 3, multiply by 4. So with rule 1, rule 1 says that this determinant is equal to 1, and rule 3 says that whenever you multiply a row by a scalar, then the determinant will also multiply by the scalar. So this row is multiplied by 2, so your determinant will be multiplied by 2. This row multiplied by 3, and then you do the same thing. So that's the first observation. Then we are going to do the row operations and to kill everything. This is just an example, okay? And we want to calculate the determinant of this 4x4 matrix. So first, you can move this up. You can also move this up and move this up. You do 3 times. You do 3 times of swapping. So it is -1, you do that 3 times. After that, it becomes -1, -1, -1. And the first row becomes the last row. And then you can do some type 3 row operation. You multiply by 2 and then add it to here. And this does not change the determinant. So that's nice. After doing this, you get the same thing, except for the last row becomes like this. And I will skip some of that because this type of operation does not change the determinant. After you do this, then this element will change. But you can use this row to kill that, and then you can use the third row to kill the fourth one. And what I mean is, you use the first row to kill this element, you use the second row to kill this element, you use this row to kill this element. And all these operations does not change the determinant. So you do a lot of type 3 operations, and then in the end, you get a quantity that is equal to 5 here. So sorry, just give me maybe 2 minutes. Let me finish this example. So here is lots of rule 4. And it does not change the determinant. And lastly, you will do the same thing again. You use 5 to kill all these here, and use -1 to kill all these things. So you do a lot of rule 4s, and it does not change the determinant, but in the end, it becomes -1, -1, -1, 5. Now, this guy has the determinant equal to -1 to the third power, and then multiplied by 5. And when you go back to the previous matrix, the determinant is the same, multiplied by 1. Because it is lots of rule 4, and these 2 steps does not change the determinant. So this guy, the determinant is -5. This guy, the determinant is also -5. But when you go back from this one to this one, you swap the 3 things, right? So when you move back, you will have to multiply by -1 to the third power. So now you know matrix A, the determinant of matrix A is equal to this quantity, and then multiply by 1, by -1 to the third power, which is equal to 5.